Hi, it's Martin, Martin's Engine Services. Right, so it's time for part 3 of the stock car engine build. The cylinder head is sitting in front of me, all the valves are in. I've just put the valve springs in. It's a fairly tedious job, getting the collets down in here. It's a bit of a fiddle, but I've got quite a good system worked out for it now. Get the valve clamp in the right place. Get an inspection lamp down there so you can see. Bit of grease, pop the collets in. I've tapped all the collets to set them, so it's now time to put the cams and all the other good bits in. Glue up the old cam followers a bit. The old cam works. These hydraulic lifters have proven to be very reliable in these engines, considering what they've been through compared to other manufacturers. What it used to go in. Hang on a minute. Okay. What's the major malfunction with that one then? Remember the old ones on the Audis and Golfs and everything? They were absolutely awful things. I've got it cockeyed in, it doesn't want to quite... I'll come back to that one. I've got it wedged at a slight angle, I'll have to grab that one in a minute. They used to fail on a regular basis, but these poor old, well, not poor old things, these old things are exceptionally reliable. I mean, bearing in mind they've been revved well past their design sort of tolerance and specification, and what they go through, they seem to be exceptionally good. You see they're all rotating nicely because you've got the nice pattern on the top where the cam strikes them off centre and they rotate to keep everything wearing evenly in the bore. So, yeah, I don't think we've ever changed the set of it actually. I'll hammer that one down in a minute. I'll turn the camera off and I'll beat it in with a big hammer, so that'll be alright. Nothing to see here. Only joking. They're quite a tight tolerance actually, so if you get them a little bit on the cockeyed, they ain't going in. Of course, that to do it while you're watching, but that's the realities of it all. This set actually came out the other engine, so it was a spare set, so they're not in any particular order. And they don't seem to be fussy if you mix them up, so we've mixed and matched them in the past and they don't seem too fussy about it. I don't know about the set from the spare cylinder head because I think they've been sitting around for a long time. So I thought, right, we know these ones were working fine. Well, the engine was a bit gritty inside, so I thought, well, I'll use the set that I know, or seem to be in the best of order. Right, let's go back to fighting this one here that I managed to have got. Well, I managed to get that one quite well wedged, haven't I? I know this probably isn't the most approved method of dealing with it, but I've got to grab it somehow. It is hardened steel, so it shouldn't make any difference. I know this looks completely wrong, but there we go. So why has that one been so awkward then? Can't see any reason why. There we go, see? There's always one. Now, no particular order. Start with the exhaust camshaft. No, don't oil that bit, Martin, that's where the gasket goes. Ignore that bit. I will pour a load of oil over there before, once I finish the engines, what I normally do, fill them up from there, so it's no real problem. The camshafts do look exactly the same. Ironically, I have exactly the same part number on, which is quite a GM bit of logic, but the pin is in a different place for timing location, and the inlet cam does have about 0.5 mm more lift on it. So they will totally interchange, but they won't time up. There is quite a nice position in these cams when you get them in. Oh, it's a bit of luck. Where you can get them almost sitting perfectly. Obviously, you don't want to put them in sort of like this and then try and do it up with the and you go put it up on the skew and run the risk of breaking bolts and bits and pieces. If you find the sweet spot, they will sit down quite nicely. All the cam caps are labelled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the numbers all point outwards because usually there's no locations on them and they are totally symmetrical. So all the numbers point away and away. A bit of oil on the bolts, on the heads. These aren't torqued up to much at all. There's quite a low specification. If you do get any sort of resistance between the bolt head here, you might not get a true read. In fact, they only tightened up literally finger tight, which is quite bizarre, but that's what GM say, and that's what I do them to, and we've never had a problem. Trick is not to pull them down too quickly because the cam will have to sit slightly into position. You can see that one's just starting to skew up a slight angle now. So it's gently. Why I do not like when you see all these people sticking these things together, zapping everything down with cordless battery guns and air tools. It's not a good idea. Again, it's a small bolt, low torque into alley. Although there's quite a bit of thread, there's 10 mm plus of thread in there, so never seems to be a problem. Some of these heads have had apart lots and lots of times, and these seem to be quite resilient, have been reused again and again. The ones that are a major problem on these, I mentioned earlier in the other, I think part 2 is part 1 is the oil pump bolts strip out, and these cam cover bolts do tend to strip out. Again, all I do there is go from M6 to M7. You could go M8, it's not a problem. That's all gone down nicely now. Let's get it away. There she goes. Right, that's that for the moment. Right, now the camshaft seals. A bit of oil on there. I just feed the seal up and it pops nicely on and set it in against the groove. Now comes a very important part of these. I've lost the gasket sealer. I'll be done with that. Okay. Martin done with the Permatex. Found it, follow the trail of destruction, or construction it should be. Now on these bearing caps, you have the groove where the oil goes round, and the groove here for the oil. You also have these two little slots here. This drains the oil back from the oil seal into the head. Now the cam cover gasket runs around this area here, around this lip here. Now you have to put a very small amount of gasket sealer here just to stop the oil seal leaking in this area and here, and the cam cover leaking through there. However, you do not want to get any sealant in that groove there or that groove there, otherwise you will end up with a load of oil behind the front seal and possible leakage. That's all you need to do. It's a do not soak them with oil job. That's as simple as that. It's do not put the rest of the tube you didn't use on the sump round there. Now the seal may not sit level with the cap, again it's a casting. As long as it's sitting in there against the bottom one, fine, that's all you need. Perfect. A little bit of silicone or Permatex has come out here each side. It's just what you want. You don't want to see it back here. That is actually the end of that groove there, and the oil will come back around here, back in there, and likewise this side. So the cam cover gasket clears it. It's very important that it's not blocked up. Now, amazingly enough, these are only done up to 6 foot-pounds, or 80 demi-newton meters. That's it. I mean, it seems remarkable, I know, but that's what GM specify. That's what you do them to. We've never had a cam fall out. Bearing in mind the thousands of revs per second these camshafts will be doing at high RPM, it does seem a bit bizarre, but that is it. It's literally no more. You can actually tighten it with a speed brace tighter than this. I won't put any pressure on this at all, and that's it. One stage torque, no angles, and that's it. One cam in, just rotate it, see if everything's okay. Bizarrely enough, it's 23mm here for some reason. Of course, you can never get the spanner to go in where you want it to. Okay. Go and get the sprocket, it might be easier. Now the sprockets will fit either way round. They both have the same slot arrangement, but the timing position, the timing marks will be wrong. This is the exhaust cam one, and it has this sensor on for when it has the camshaft position sensor. That's just redundant now, we just use the pulley. To make things even more confusing, the inlet one is marked 16XE, which is actually an 8-valve engine. So they just use that as the single sprocket there on the 8-valve. They use it as the inlet on the 16-valve. But of course it says 16XE on there, just to make things a little bit more interesting. That caught me out in the past thinking, is that the right one? But nope, that's how they did it. Hello, come back. You see, there's quite a lot of load on the cam to turn it. To get some idea of what the cam belt's going through. That all turns nicely. I think we'll give up that spanner. There is no need to set the cam in any particular position when you fit the inlet cam, because on this engine the valves can't meet up. I mean, on some 16-valve engines with inclined valves, the inlets and exhaust could meet up if the timing's out. So you fit in one side, you turn the other, and you can crash the valves. These are a long way away, so it's not a problem at all. So you don't need to time them up for any particular reason. And in fact, amazing enough, I think this one's actually stopped. No. For safety's sake, whenever you're doing any engine assembly, an overhead camshaft setup, they always position the pistons halfway down the bore, so wherever you put the head on, you're okay. Now, someone in the past done a belt on this. You see they put their own marks there, another mark on the factory mark. So you've got to be careful of that sometimes. I'll take them all off and just go by the factory one. Don't all put your own on. If there's no other marks, put your own on, but don't follow anybody else's, because you can go very badly wrong. You don't want to start crashing valves and pistons. And I do know of a guy who worked opposite me in the last yard I was in, who very confidently was trying to time a chain driven version of this engine, one of the later ones. It was in a Corsa. He'd done a head gasket on it, and he said he wouldn't wait for the timing tool. He said, "Oh, don't worry, I've worked it all out, it's absolutely fine." And the one thing he didn't do, of course, was a safety check. It's going to fit one way. That one's sitting a little bit high, but we'll pull that down. So he didn't do a safety check, and he confidently put it all together, and he turned the key. And I heard from the other side of the yard this crunch, ping, snapping sound of valves meeting pistons and chain snapping and whatever, and he proceeded to hang on the key for about 2 or 3 minutes, and you heard the smashing, and when the smashing sound had stopped, it was whizzing over quite happily, and of course it smashed valve into valve and piston into piston. Resulting was he bent all 16 valves and split all 16 guides, and he just had the head rebuilt because he diagnosed the engine as valve stem oil seals, which turned out, of course, not to be a Vauxhall engine. It was piston rings. So it just goes to show you, but it was a case of, don't worry, it's absolutely fine, I've worked it all out mathematically. Now, I am obsessed with doing safety checks. When you time an engine, cam belt's on, it can't be wrong, but I like to check it again and again, at least 3 or 4 times, so I'm 100% certain it's perfect. Do not take that chance. And as for working on the theory, you got to be very wary of this. Some engines you think, oh, put the cams away from the valves, that's fine. It's not always the case. Sometimes you might find the cam is here, it's here when it times. It can be different. Do not presume that it's going to be cams opposed and piston at the top. I mean, the Rover K series is timed halfway down the bore as a safety feature, which is quite a good idea. And of course, if you just sort of guess that one, you'll never get it right. But it has to be said, that was quite a spectacular amount of noise. I was actually sitting in my workshop doing some paperwork, and I heard all this crunching, and you sort of wince at the first sound, and you think, surely he's going to stop. No, we'll keep going. Well, I guess he made a thorough job of it. He obliterated the whole lot, and apart it came again. Back to the machine shop for another complete head overhaul. Whoops. He actually did a similar thing to a 1.6 Ford Focus, a similar version to the Puma engine I'm doing. And what he managed to do was diagnose that as stem seals, which again was definitely piston rings. And he pulled the head off, had the head totally overhauled. Put it all back on, and the thing smoked like a good one. So he took the head off, took the sump off, new rings in it, new bearings, put it back together, problem solved. And he sent his guy out on a road test. And this is where it gets kind of really embarrassing. His guy's going down the road, and he hadn't done up the crankshaft pulley bolt properly. Now on those engines, obviously it's the timing belt sprocket is held in place by the front pulley being tightened up. So there's no woodruff key or anything, so the pulley flew off, timing went out, and smashed all the valves up. Now, more than embarrassing for that was the fact that the customer of the vehicle, actually driving along just as this happened in the other direction, his other vehicle, and gave his guy a lift back to the yard, whereupon he got out of the other vehicle holding the pulley, the bolt and the alternator belt, and they towed the car back, and yes, you guessed it, 16 valves, 16 guides, all nicely smashed up, so they had to do it again. So I think we could call them boomerang motors. In fact, I could probably make you a 2-hour plus video on some of the stories and destruction and chaos they created, so it's always a good guarantee a bit of a laugh. But I'll never forget that. Every time I do an engine and a camshaft, I think, don't worry, I've worked it all out scientifically. Wrong. So I'll always remember that. It was just the sound of all the smashing and pinging and crunching going on. I mean, obviously, when it's a chain-driven engine, it's even worse. I mean, with a belt, you might shear the belt off and it will stop, but of course the chain just kept dragging everything round out of time for, well, while he just kept going, basically. So, but okay. Ironically, the timing tool he ordered arrived the very next morning in the post while he was examining the wreckage, so it was a case of why not just wait. I've actually made up my own set of timing tools for timing those later engines. It's quite straightforward. There's a thing in the block, a plug in the block and bits and pieces. There's no great complexity, but you do need them because they're another engine that doesn't time where you think. And you have to time the inlet sprocket for the inlet like camshaft position sensor, so it's fine. We'll set it near enough. Yeah, so I think there were two jobs, were only a couple of months apart, so I have to say they didn't actually ever make any money, and they didn't last that long. I think there's a moral to be learnt there. Very nice guy, but really think he should have took a bit more time. In fact, he was one of those people who was very capable, but never got it quite right. I often go back and check these because they can sometimes just seem to loosen up a little bit once they settle. So I just like to go back and double check them on the safe side. And that is basically cylinder head ready to fit. As you can see, this sprocket here, the timing mark is there. This is set up here. The cams are not directly up. They are only 90 degrees around from the valve, and the pin on the camshaft is pointing that way. I don't know how far out this one is. This one's got a fair bit to go. We'll do a spanner. It probably won't work because we tried it once before, but of course not. No chance. Defeated. Now this one, the pin in the cam is almost vertical. You can see, but the valves again are opposed that way, but not quite as thick. It's quite round as far. Yes, as good as, probably about there. So you can see effectively it's lobes away, but the pins don't make any logic. So you could end up with quite a conundrum if you get it wrong. So there is the head, ready to attach to the engine. That's all ready to go. Some of the hydraulic tappets will probably be holding open a little bit because they will have pumped up while there's been no tension on them. But overnight they'll go down with spring tension, although they don't look too bad. Those ones should be open. And should be open on the overlap. No, it seems okay. You have to be obviously very wary of that. If they are hanging out a long way, obviously you put the head on, even if it's in time, you can turn it round and hit the valve. So certain times you've got to be wary, but that won't be going on till tomorrow now probably, so I should do that. So now it's just a big case of sticking that bit on top of the other bit, putting the timing belt and all the other goodies on, and we'll nearly have a whole engine. So I shall bring you along for that one. It should be the grand finale. So hope you enjoyed part 3, and so please like and subscribe. It's very much appreciated. It's been quite good fun making a making an assembly video like this. Filled up an afternoon. It's been a very pleasant day, and I think it's time for yet another tea break. So again, thanks very much indeed for watching. It's very much appreciated. Bye for now.